Hello, hi everyone. I'm Saurabh Arora. I'm a Google developer expert for Android. And today we'll be covering some privacy changes and like what are the new privacy changes and how you could adapt your app for these new privacy changes that have been introduced in Android 11. All right. So over the last couple of Android releases, there's been quite a lot of focus on privacy. And these changes are really important because smartphones contain a lot of information about our lives. And it's important that, as a user, we trust the smartphone that's in our hand. So with this mantra in mind, Android has made a coordinated effort over the last couple of years to make it a more privacy-centered platform. And these efforts continue onwards in Android 11. Like, for example, Android 10 paved the way for changes into location permissions, and these kind of features are being exemplified in Android 11. So today we look into some of the new changes that are introduced. This will revolve around permission changes, foreground service types, scope storage, package visibility, and a new feature called data access auditing. So first up, let's look at permission related changes that have been added in Android 11. So in Android 10, actually, when the users were presented with an option to select like when the location dialog came up in Android 11 and users were presented with an option to select allow only during foreground, users ended up selecting that option nearly half of the time. All right. So with that in mind, like because users are getting really more privacy centric and they like to restrict access to permissions that's been given, Android 11 extends these granular control to users' private data over to microphone as well as camera, and also significantly limits access to background location for your apps. Now, in Android 11, along with an option to say grant this permission while using the app, the dialog will also have an option which says, oh, only grant this permission only this one time. So there's a third option that's been added to this. All right. And that's just not for location. Like my previous example was based off on location. But for Android 11, this new option to grant permission only this one time has actually also been extended to microphone access. Like, for example, if you are let's say a transport app, right? And you have a feature inside your transport app for VoIP call. Like, let's say you want the driver to connect with the rider. And at that point, the user decides to make a call. So following the best practices for permissions, you ask for the permission at that point. And the user is like, hey, I don't feel comfortable letting you record my audio all the time. So there'll be a new option saying only grant this time. Like the moment the user is wanting to make this call to connect to the driver in this example, the user can say, hey, I only want to grant the permission only this one time. Similarly, the same one-time access has now been extended to camera. Here, I would like to emphasize that this is added only for location, camera, and microphone. Other permission accesses currently do not have an allow one time. They will continue to have just the allow and deny options. All right. So as developers, we would be wondering, what do we really need to do to prepare our apps for Android 11? Like, is there something in particular that we need to do for this? Well, to be honest, if your app was following the best practices for permission access that was detailed in Marshmallow, so Android 6.0 was when dangerous permissions and the concept of requesting for permissions was introduced. If you were following the best practices that have been laid down over all the last years, then essentially your app really does not need to do any changes. Everything should just work out of the box for you. So, I've multiple times emphasized that if your apps were following these best practices. So here, I would just do a short diversion and have a look at what are these best practices that we're talking about. So anytime a user needs access to, like anytime your app needs access to some private data about the user that is behind a dangerous permission, make sure to check before you actually go ahead and access that private data. Make sure to check that does that permission actually been granted to your app, and make sure to always check for that permission. You should never cache the state that, oh, I was granted the permission previously, so I can just cache it and stop checking it. Nope. Your practice should be to always check for it because permissions can easily get out of sync. This user can go into system settings, go to your app, and revoke a certain permission that has been granted to you. So never cache the permission state. So always request for the check if the permission is granted to you before you perform any action. If the permission is not granted, go ahead and request for it. If the user denies the permission, then fall back gracefully and explain to the user that the current functionality that the user is trying to access will not really work because the user declined the permission request. So if you're following these practices, none of the changes introduced as a part of the one-time permission grant will actually have any impact in terms of your code base or the changes you need to make in your app. Another point to highlight here is, even though this is a new feature being introduced in Android 11, the one-time permission change will actually kick in even though you've not updated the target SDK of your app to Android R or Android 11 or API level 30. So even if you have an app which targets Android 10 and it's installed on an Android 11 device, the one-time permission prompt will still appear. The reason being, there's an inherent assumption that the apps will automatically handle this out of the box, because ideally no code changes are needed for this if best practices were being followed. So this could be a feature change that they could introduce, like the Android team can introduce in Android 11 without breaking your apps. All right. Okay. So previously, when we looked into this one-time permission access, I mentioned that like Android 10 split location permissions into foreground and background, and Android 11 actually puts more changes onto location permission in particular, because location permission is special. Users can sometimes get worried that apps are continuously tracking them. So for this, Android 10 split it into foreground and background. And what Android 11 does so in Android 10 they made an option that you request for foreground access and you request for background access, but you could request all of these two permissions together. In Android 11, actually the process has now become incremental, because there's you'll see it in the next example of what do I mean by incremental. So on previous Android 10, when you said, hey, grant this permission, you actually had an option, right? The users could say allow all the time or allow only when in use. Allow all the time meant allow background permission request, allow background location access as well. This is slightly different in Android 11. When you say I want background location, this will be a two-step process. First up, the users will get an option to say, hey, the app is actually asking for foreground location permission access. Notice there's no option over there saying allow all the time, because that all the time is now removed from your permission request. So the user first has to say, hey, yes, I'm okay to grant foreground permission access to this app. Once the user says I can grant foreground permission, another dialog will appear which will inform the user that this app also needs background location access. And no longer can the user grant background location access in app, because allow all the time has been removed. So what now would happen is there is an explicit call to action, which will take the user to the system settings, where the user has to explicitly again grant background location permission to your app. And do note that at this point, there's still a deny option. So what the user could do is the user could grant you foreground, then because you ask for background location, it will take you to the system screen where there's a deny option and the user can deny it. Deny like all the location permission that was given to you. So this is just a gotcha. Like, I just wanted to highlight that again, the importance of checking permissions every time you perform an action. Like the foreground was granted, but because of a request to background, even foreground was revoked. So when you come back to the app, don't just assume you have the permissions. Make sure to check before taking any action regarding permissions. Also regarding accessing users' private data, which are gated behind permissions. So this change actually takes place if your app is targeting Android API level R. But if you're not targeting Android API level R and your user is running your app on an Android 11 device, the allow all the time option is still not available. That will still not be presented to the user. Instead of a two-step process, the first dialog shown to the user will actually be a expanded dialog, which will have an option to ask user to go into the system settings and explicitly grant the permission to the user. Also note, when I said go into the system settings, uh, the prompt that appears both when your app is targeting Android R or not targeting Android R will have a call to action which will deep link the user to the system screen. Okay, so staying with the theme of permissions, let's look at auto reset permissions. So auto reset is, let's say, an automated process of revoking permissions that have been granted to you. A lot of users install a lot of apps, and then we just want to use it one time or a couple of times, and then people just tend to forget about it, and those apps just keep on lying on the phone, continuing to access sensitive and private data of the user. So auto reset permission is a way that if an app on the device has not been accessed for several months, the system will reset the app's permission. And look at it like being exactly the same way as the user going to system settings and revoking the permission from your app. This will behave exactly the same way, just that now the system is doing it for you. All right. And when the system auto revokes the app permission, the system will inform the user through a notification in case the user wants to take an action and grant back the permission to your app. But I figure here a lot of people have questions about, hey, what if my app primarily works in the background? Because I said if the system detects your app has not been used in the foreground for a couple of months, it will auto reset. And you're like, but my app primarily works in the background. Mine is a smart device connectivity app, or it's an app which automatically syncs the user's data. So it's just always working in the background. The user never really needs to open it. So for such apps, you can actually educate the user in app, letting them know that, on Android 11, my permissions will be auto reset, the permissions you've granted to me. So you can ask the user via this new intent flag that's been introduced, which will take the user to the system settings screens where they can disable auto reset permission revocation for your app. So the users will actually go back to this screen where they can disable this auto reset permission. So there is a way to opt out for it, but it's under users' control, and you should educate your users that, hey, please don't auto reset my permissions. And as usual, be careful when using this. Your app should really have a very valid use case that it needs to operate in the background for the user, and hence you're asking them to remove the capability of system auto resetting the permissions for your app. All right, so that covers permissions. Next up, let's look at the new foreground services that has been added in Android 11. So Android 10 had actually first up introduced the concept of foreground service types. So what this meant is, if you're running a service in the foreground, you're running a service which is displaying a notification to the user, you could access users' private information inside that service as long as you explicitly declared your intention in the app's manifest to do so. So it had introduced foreground service types for, let's say, syncing, media player, phone calls, media projection, location, etc. But actually only 2 of them were enforced. What I mean by enforced is, even though there were new foreground service types included in Android 10, enforcing meant that only for location and media projection did you actually need to say that, hey, explicitly mention in the manifest that I will be accessing private data. For others, even if you did not mention, you could get away with it. Like, you could just create a foreground service and try to access phone call information without actually specifying it as a foreground service type, and the system would still let you access. But for location, that was never the case. You have to explicitly define it. And now in Android 11, that explicit definition includes camera. So if you want to access camera information using a foreground service, you have to mention it in the manifest that this service is going to access camera, so that the system can let the user know that there's a service running in the foreground via notification, which is accessing the user's camera. So over here, I do foresee a few changes for developers. I know a few, I've seen open source projects and talked to a few developers where they use the foreground service as a way to warm start the camera before the user actually uses it. So if you're doing something like that, inside your foreground service, you'll need to define camera as a foreground service type so that the user knows that something is using the camera currently in the foreground. Oh, not the foreground, like something in the system is current, that your app in the system is currently accessing camera. Okay. And I mentioned there was a foreground service type for location in Android 10. Android 11 added camera. And mostly, as we saw with permissions, camera and microphone go hand in hand. Like there are very few use cases where you just want camera access and don't want microphone access, right? So for Android 11, same thing. You also have a new foreground service for microphone, which is enforced. And now you can have the same service which can access multiple types of private data. So you can have one foreground service which specifies that I want to access both camera and microphone information. Just one clarification here. When I say foreground service types, you need to define location, microphone, and camera. That is an additional indication to the user that you'll be accessing these kind of information using this foreground service. It hasn't got anything to do with permissions. So permission has to be granted for these location information to anyways be accessible in your foreground services. So following the best practices, make sure in your foreground services as well you're checking that yes, permission has been granted, and B, in the manifest you've declared your intention to access these kind of informations. Okay, so those are about permissions. Next up is package visibility. So in Android 10, the API allows, so in Android 10 and previous APIs, you could actually check list of all installed packages in your app via the package manager. This would return you all apps that are installed in the operating system. And in Android 11 or Android R, this gets slightly restricted. Apps can no longer query all type of apps that are installed in the current user's device. So here the question might be that what happens to a lot of common package manager cases, because as I've said, you cannot use package manager to query everything that's installed in the system. A lot of these common use cases actually don't change for you. So what am I talking about by common use cases? Like, let's say you want information about your own app, that doesn't change. If you just want to query about system packages, this also doesn't change. Like the get installed packages method now will return you all the system apps that are installed in your app. It does not return you any third-party app which you do not own. That doesn't change. If you're sending implicit intents to, let's say, capture images, because it's an implicit intent, you're not targeting any particular app. You're saying anybody who can capture an image, go ahead and capture one for me. This also doesn't change. So these kind of usages of package manager actually don't change for you. All right. And lastly, if you're using content providers, this also doesn't change, right? Because content providers are also explicitly declared, and you can query them and get information even though the content provider is a part of the other app. So nothing changes on this aspect. What really changes is if you're trying to access information if a certain specific app is installed. Like let's say you wanted to access this another app, and the system will always now in Android 11 return you name not found exception, even though this app might be installed. So let's say you really still want to know if certain apps are installed, maybe because you want to have image sharing functionality in your app. Like you want to be able to share images. So you want to know which all apps exist in the system which can share images, or you're working in an organization which owns more than one app, right? And you have protocols inside your apps to be able to communicate with each other. So you need visibility, hey, if that other app is installed in the system. There's still a few ways to do it. Basically, in the manifest now, there's a new queries attribute where you need to specify explicitly, list down the packages that your app cares about. And then when you do get installed packages, the system packages, along with these explicit packages that you've defined in the manifest, they'll also be returned back to you. If you want list of apps that share certain kind of metadata, like in case here you need to know apps which are able to get access to JPEG images, you can also specify intent filters inside your queries attribute that, hey, my app needs to know any app in the system that is able to handle the intent for image JPEG. So these kind of exceptions are still there inside the package visibility. So it inherently needs to be extremely explicit instead of just saying, give me everything, right? And in case you still have a very exceptional use case where really, really need access to all the packages that are installed in the system, and you really cannot work with this new protocol of restricting access to define what kind of apps you can know about, or having to define upfront that these are the packages I'm concerned about, and you really need access to all apps, there's a new permission introduced called query all packages in Android 11. You can include that in your manifest, but do note your distribution on Google Play for this with this permission will actually be gated by a new Google Play policy that which is actually supposed to come out in a couple of days, if I'm not mistaken. This policy will list down the standards and what is expected of your app if you want to publish an app in the store which has a query all packages attribute. All right. Okay. So another example I wanted to highlight, which I personally had a question about, like how this would work, is essentially this is also an intent I'm sending off, right? And what us developers do is at this point we would actually use the package manager. Like I've just put an example that if you do this, what the system does is it would actually triggers a disambiguation dialog, right? Do you want to select the browser? Do you want to select the app? So what developers do to get around this is we use the package manager. We'll use the package manager. We'll give it this intent, see what kind of apps are returned, and go through all apps that are non-browser and actually use that to launch, because we don't want the user to see this disambiguation dialog. And now, as I said, package manager is restricted. You cannot actually do this unless you explicitly declare that in this example, Google News is what I want to be aware of. And you cannot do that. Like you might not want to do that. So in this case, what you could do is there's a new intent flag called flag activity require non-browser. You could actually use this and the system will do the same thing for you. Now the system will check for you that I will use an app that can handle this, and the app should not be a browser. But in case that's not possible because because the user never really has, let's say, the Google News app in this example, then the system, as usual, will throw you the activity not found exception, which you can put a try catch around and then continue on with the regular behavior of launching a browser, or remove this flag and then let the system take a browser which can open this URL for you. So that use case of package manager just to handle deep links into an app should also go away with flag activity require non-browser. Okay, next up, data access auditing. So, as we mentioned, the best practice is be transparent to users, like let them know what data they are accessing. And it should also be clear to your app why you are accessing this data. But it's easier said than done. Sometimes we're working at large organizations where there's a lot of orphan code. Accidental data access keeps on happening. Teams have moved on, and developers might not know that in certain part of their code base, a certain piece of code is actually accessing one of these private data of the users. Another use case is sometimes third-party SDKs would be accessing private information of the user, piggybacking on the permissions that were granted for your app to access, but not explicitly to pass it to the third-party SDK. And they might just be doing it because the permissions are granted for your app. And you don't want all of this to happen. Or let's say you really want to know when these kinds of access patterns are happening. So in Android 11, what you could do is Android 11 actually introduces two new APIs to allow developers to be aware that when this kind of accidental or intentional data access is being triggered. So the basic feature is actually a callback, which is triggered when such kind of private data is accessed. And along with the callback, you can actually also attribute this private data access to certain logical features inside your app. What I mean by this is, like, let's say you have a bunch of code and there's a spaghetti code and you're accessing certain parts of code, are accessing location, somebody's accessing camera, somebody's accessing microphone, and you really want to know when this certain access is happening. So in Android 11, you could there's a new apps ops manager service, which provides a operation noted callback. Now, what this callback is that as soon as your app accesses private information of the user, which is gated behind a permission access, your system will call you in with the stack trace of the code where this permission access took place. Like a stack trace like you get for crash reporting, right? You would get essentially such a similar stack trace pointing you to the position in your code where you actually requested access for this permission. So it's at the point the permission was being requested rather than at the point where the permission has been granted and you're performing data. So just a small thing to note here, it's at the point where you request access to this permission or this private data. All right. And if you want to capture this information throughout your app, you can create a global app callback inside application on create. But if you want to do it at the fragment or activity place, you can do it in their life cycles respectively. Okay? And as I mentioned, you could get information about the stack trace. You could also tag those stack traces or certain parts of your code to certain features. Like let's say there's a find friends feature and you want to rest assured in your analytics tools that my find friends is only accessing contacts and location permission, right? It should never access microphone, even though my app has microphone permission, but the find friends feature should never access it. So you can do that as well, like to prevent such kind of accidental access. What you could do is you could create an attribution context and just create an attribution context. Now, in the same app ops manager where you were getting the callback, you will get this attribution log. So you would get this attribution tag, which will have the same value as the attribution context that you set up. So you can verify those two of them together and conclude that your find friends feature is only accessing these level of permissions. Where is this something like this helpful? Like now you can actually see through your analytics that my find friends is actually accessing only location and contacts information. So it also helps you audit that yes, my feature is only accessing the required permission. It also eventually will help you build better user experiences to the user where you can explain that when find friends is working, what kind of permissions are you accessing. All right. Okay. Next up to talk about scope storage. Okay, so before the introduction of scope storage, okay, sorry. So let's talk about scope storage. And before the introduction of scope storage in Android 10, actually you had two classifications, right? App storage and scope storage. And Android 10 tried to limit access to shared storage by splitting it into media files and other documents, right? But in in Android 10, scope storage was always optional. Developers could still say, hey, this is a big change and I'm not really prepared for this. I would like to request legacy external storage in my manifest. And with that, you could still work with the old storage format. That's no longer the case in Android 11. Unfortunately, now or fortunately for the users, scope storage is now compulsory. Like if you're targeting Android 11, you have to opt into scope storage. So most of the scope storage stuff from Android 10 is exactly the same. So whatever changes were introduced in Android 10, more or less are the same things in Android 11, except for a few minor tweaks to make life easier for both users and developers. First up, in the dialog, it's no longer called storage. It will be called files and media to make it more explicit for the user. Next up, bulk access is made easier. So in Android 10, if you want to edit or perform any action on a file which is not owned by you, and the user wants to perform access on 10 different files, the user would have to grant access to 10 different files individually one by one. But now we have a bulk API, which is like you can bucket together all the list of files you want to access to set off an permissions intent to the user, and the user can grant access to all of those 10 different files in one go rather than have to do it like Android 10 where they have to grant permission one by one, which was actually really tedious. And once the permission is granted, you can take access on all 10 of them together. In terms of action document tree, so if you're using a file picker and you want permissions and you want to be able to access documents of the user and you use the document tree flag, you're restricted to not being able to read anything inside the downloads and the Android data and OBB folders. Those are off limits now. If you use action open document instead of document tree, then Android folders like data and OBB are off limits. Download folder can still be accessed under action open document. So you can still get access to documents which are inside the download folder. Lastly, manage external storage. If you really need an app which needs full grain permissions rather than under scope storage, like you need access to all the storage of the user, that's still possible. But again, just like the Package visibility, this is gated behind a Google Play policy. Like if you're a file manager, you'll have to go through the Google Play policy, make sure you're not breaking any guidelines, and then you'll be able to publish such an app into the store. All right. Now, just a quick turnaround onto some other nitpicks and some other few other minor privacy changes which we cannot bucket under specific tools, specific sections. Phone permissions have been restricted. So earlier, the read phone state would give you access to calling state, which is generic info, like is the phone ringing, is the phone idle? But that would also give you access to the phone number of the user who's calling in, right? Through read phone state, you could actually get that information as well. That's restricted now. Now, through read phone state, you only get access to the calling state, and there's a new permission introduced called read phone numbers if you need access to the phone number as well. All right, and you can declare that new phone number permission in the manifest and put a max on the previous one because that only gave you access for the ringing and the idle information. MAC address is now restricted. If you apps can no longer address MAC addresses for network interfaces, that's been something of an ongoing trend as of Android 10, 9, and now in 11 as well. Uh, System alert window has also been restricted. This was anyways removed in Android Go builds, but now in Android 10, it could no in Android 10 it could no longer be granted in app. In Android 11, you can no longer deep link to the system setting to grant. You have to deep link to the generic app list where the user has to explicitly find your app selected and then grant permission to draw overlay windows on top. As was mentioned in the previous last talk, Bubbles is a great replacement for this. So if you are using this for kind of a messaging kind of an interface, use Bubbles instead of using system alert window. Adapting to changes, I think this was covered in the previous talk as well. There's a new app compatibility framework in the developer options where you can specifically enable certain features for your app even without targeting Android R. Since most of them come into place when you're targeting Android R, you could go into developer options, enable this, and test your app for each individual change one by one and see how you can adapt your apps for this. And just one more thing to highlight for app compatibility, uh, it you can only change behaviors for developer builds, like debug builds. You cannot take a production app and be like, hey, enable auto reset permissions for this, because that app doesn't support Android 11 yet, so you cannot modify its behavior. But if you have a debug build, the idea being you own the debug build, you can start to modify particular behaviors for that app. That's it. That's a wrap up. A lot of privacy changes. Most of them, if you're doing best practices, it should be a straightforward migration, no changes needed. If you opted in scope storage in Android 10, again, should be more or less straightforward. And that's about it. See you at the Q&A later in case you guys have any questions. And if you want to send off questions in a different way, feel free to follow me on Twitter and post your questions over there. I'll gladly respond. Thank you.
Thank you, Saurabh, for